So my message for all of you is don't be afraid to fail. And search for opportunities to fail early, fail often, and then converge quickly and learn from those failures. A lot of times when you fail, it's the best opportunity to improve. Now, NASA also used to be okay with failure and took a lot of risks in development and test. But over time, NASA got more and more risk averse. And when I left NASA, we were getting very, very concerned, and it was really hard to innovate. Because it's a very natural human reaction. After you endure some terrible tragedies, and we had Apollo 1, we had Challenger, and we had Columbia. And I was there for Columbia, and it was one of the most painful experiences in my entire life. Once you live through something like that, you never want it to happen again. But the natural human inclination, when you're trying to prevent another failure, is to not change anything. Because you can become terrified of an unintended consequence of a poorly thought through change. But I would assert that all of our major failures, Apollo 1, Challenger, Columbia, occurred not because we changed something and didn't think it through. All of those failures occurred because we should have changed something, but we didn't. And in SpaceX, the culture is completely different. The SpaceX culture is all about trying to find ways of doing things better, continuously improving, and trying things. Now, there's another thing that SpaceX enjoys. One of the biggest differences, other than the free frozen yogurt, which was, we didn't have that at NASA. But the bigger difference that you don't see when you walk through and take a tour of the factory is the decision speed. We would make a decision at SpaceX in a day, sometimes an hour, that would take up to a year to make the same decision at NASA. Now but there's a danger there, of course, right? If you make a quick decision, the danger is that you make a wrong decision. But what SpaceX had, that unfortunately NASA didn't, is the agility to quickly change direction once you realize you're making a mistake. The idea is go out and try something quickly. If it's wrong, pivot, do something different. We had the ability to do that. In a traditional aerospace world, when you have a lot of suppliers, subcontractors, and contracts, it's very difficult to make major changes to the architecture. It's very costly, very time-consuming, and it will kill the program. But at SpaceX we could, and that enabled us to move much faster. So it was a different world I was entering into. And during that time, right around that time, in 2011, we landed the very last space shuttle. And for 9 painful years, we had no ability to send men and women into space. All of our astronauts had to get rides with the Russians on the Soyuz rocket to get to the space station. But during that time, NASA and SpaceX partnered together, worked together in a program called the Commercial Crew Program. And working together made this new rocket and new spacecraft. The Crew Dragon and the Falcon 9 rocket improved for human flight. And on May 30th, 2020, we launched this rocket for the first time with people inside. And in case you missed it, I'm going to show you a quick video of what it was like on that day in 2020.
Work goes along just like this game over.
2, 1, 0. Ignition. Liftoff. Godspeed. Fun flag.
It's really looking like a good flight. We got a ways to go here. So far it was beautiful. It's just feeling dreamlike to see that thing actually take off.
just so proud to represent SpaceX and NASA in this new next launch capability.
MD Houston flight. Houston is go for undocking departure.
Dragon committed to undock.
But to me, a lot of what we're doing really harkens back to Apollo. I remember taking Bill Anders, Apollo 8 astronaut on a tour of SpaceX, and he remarked at how SpaceX today reminds him so much of what NASA was like during Apollo. Back during his flight, Apollo 8, back in 1968, was another difficult time for our country. We were losing a lot of Americans in the Vietnam War. We had racial conflicts and violence, and we had a big division in our society. Obviously, there's echoes to today. When Apollo 8 came back and successfully orbited around the moon, a telegram was sent to the crew saying, "Thank you for saving 1968. Now, I'm not saying that Bobby Love just saved 2020, okay? And I'm not saying that what we just did is anywhere near as technologically complicated or as impressive as sending 3 men around the moon back in 1968. But I hope if you, were like me, and for at least 10 minutes just now, you looked up and saw something exciting, something that gave you hope and a bright view of a future full of wonder. That's the magic of human spaceflight. Thank you. It was a really magical day, and one I'll never forget. But it's not the end, it was only the beginning. So there's a lot of things different about this new spaceflight and this partnership between NASA and SpaceX, and also between NASA and Boeing, which is the other commercial partner in the commercial crew program. At SpaceX, we have the Crew Dragon. You see some of his specifications up there, and you also see the Boeing Starliner. So during this program, we developed 2 different spacecraft, the Starliner and the Crew Dragon. Now, the Crew Dragon was flown many times now with humans up to the space station or on orbital missions. The Starliner has flown in space 2 times, and early next year will take its first human crew up to the space station. They launch on 2 different rockets and 2 different launch pads, so we have full dissimilar redundancy. It's been a very successful program, and it also led to the beginning of space tourism, okay, a private space flight. And you can see here that we had some suborbital companies in 2021. 2021 was the big year for the start of private spaceflight. You see Richard Branson in Virgin Galactic Spaceship 2. You see Jeff Bezos in Blue Origin's New Shepard. But SpaceX also started orbital space tourism with the first flight of paying passengers in the Crew Dragon, and that was Inspiration 4. And then the first private flight to the International Space Station, the Axiom 1 mission, which launched just in April of this year. So 2021 and the beginning of 2022, the big year for the start of private spaceflight. But what's up next? This year, 2022, is going to be, and early 2023, is going to be the year of the really big rocket. And what we have here is on the left, the NASA SLS rocket with Orion on the top. This is the vehicle that will take us back to the moon and as part of that Artemis program. And I was hoping to show you some videos of it flying today, but we have to wait a little bit longer, and that's okay. The other big rocket that we have is the SpaceX Super Heavy Booster and Starship. Now, SLS Block 1 with Orion on top is going to be the biggest, most powerful rocket that NASA has ever launched in the very near future when we do launch it. It's going to have more than 1 billion pounds of thrust more than the Saturn V rocket. It's going to have 8.8 million pounds of thrust. It's a really big rocket. But this other one, this gargantuan Starship and Super Heavy booster, has almost twice as much as the SLS rocket as far as thrust. It has 17 million pounds of thrust at liftoff. It is a beast. If you look at this picture up here, if you look at the picture in the middle, and you see those men working to bring the two parts of the vehicle together, if you see on the other picture where the black Starship meets the silver booster, they're standing right in between those two. That's how big this thing is. And the other thing about it that makes it very different from the SLS and Orion is that it's designed to be completely reusable. That not only will we get the rocket back, but we'll also get the spacecraft back and hopefully be able to just refuel them and use them again. The other thing that's very different is once that Starship's on orbit, it's basically out of gas, because it's also the upper stage of this vehicle. But we can launch tanker ships, rendezvous and pump cryogenic propellant across from the tanker to the Starship, and after multiple refuelings, and the tanks are full, it will have enough delta V to get its payload most anywhere in the solar system that we want to go. And with how many people? Well, as advertised, 100 people could take that ride at a time. Now that seems awfully ambitious, and it is. And there's some huge ifs. Trying to get a rocket that big to work right. Trying to figure out how to pump cryo of that quantity repeatedly. How to make it completely reusable without a lot of maintenance in between flights. These are big engineering challenges. But if it works, it will change everything. So stay tuned. I predict that the next couple decades are going to be just as exciting for us as it was for the Apollo generation that saw men walk on the moon for the first time. Thank you very much. Take care.